So let's look at a possible investment vehicle, kind of a new innovation that's just starting to gain traction that we think might have some opportunity to contribute here. And it's this concept called an environmental impact bond. And it's just gaining traction, but there are a couple of kind of innovative programs that are out there now, and I'm going to give you a couple of examples here. But let's talk about it. It's also known as impact investing, and the key considerations here is that this is not government funding to to cure some sort of societal or environmental problem. This is private capital that is seeking a profit, a rate of return, that investments are made with the expectation of earning a market rate, and that's an important consideration. Another aspect here is this concept called payment for success, which gives the investors and the participants skin in the game to try to make sure that the intended outcomes actually materialize. And so our intended outcome here is capture of nutrients, and the idea here is that we can leverage this payment for success incentive structure to improve the performance of the project, right? And with that in mind, it's really important to understand that metrics around performance need to be defined in advance and then monitored along the way. It is an essential element of the payback of the investment. And maybe you've heard of these also positioned as social impact bonds, right? That there have been some stories out, examples where this type of investment has been used to, for example, reduce prison recidivism or help incentivize recovery from addiction and that sort of thing. And so it's been tested and with some promising success stories, and so we're hoping we can maybe find a fit with this nutrient issue. And so let's look at a couple of examples, right? That there's one right now underway in Washington, D.C., and it's called the Water Environmental Impact Bond. And it's the challenge there that Washington, D.C. is having, like a lot of cities are having, is with combined sewer overflows, CSOs, right? That the combined sewers work great until you have a storm event, and then when the system capacity is exceeded, then it's inevitable that the overflow releases untreated sewage into the waterways, and that's a bad problem, right? And EPA doesn't really have a sense of humor about that. And so a group of investors that looked at the opportunity for green infrastructure to reduce stormwater runoff looked at this. Goldman Sachs and the Calvert Foundation provided the funding. $25 million in municipal funding was put in play. It's the largest payment for success project ever, and in this category, it's in stormwater runoff. It was put in place in 2017, and they're building it out as we speak. You can find this on the web. It's a really interesting story to go look at. But private investment looking at using green infrastructure with a return on investment for the investors and an improvement on the CSO side for society. Another one that's really interesting is what they call the Forest Resilience Bond. And so this is aimed at reducing fire risk out in the western U.S., right? That a big part of the problem is that the forests are overgrown. And the reason is because we put out the fires, and so the underbrush continues to build. It creates a fuel that accelerates the spread of the fires and that sort of thing. And the Forest Service, who manages all of this public land, doesn't have the budget to go in and maintain and restore those forests in a way that reduces the fire risk. Well, using this Forest Resilience Bond, the investors put the money in play, and the money is used by the Forest Service to do the restoration, which lowers the fire risk. And that provides a benefit in the form of fire suppression, which is reduced cost of putting out the fires, and also reduced property damage to the homes that get destroyed when the fires roll through. And there's an economic benefit there that yields cash flow back into the resilience bond. And the electric and water utilities that rely on the stability of those forests to provide site management and that sort of thing, they realize economic benefits and they pay into the bond when the performance is achieved. And so that cash flow goes back in to continue to fund the Forest Service and provide a return to the investors. And that's a collaboration between World Resources Institute and a conservation group called Blue Forest Conservation and an investment group called Encourage Capital, two real-world projects that are using private money to solve these societal environmental problems that are kind of cool. We're hoping that we can find a model that works in this context, right? So could an environmental impact bond work here? And so let's put some boundaries around this, right? That let's imagine that what we need in the state of Ohio is 100,000 acres of restored wetlands. And as we said before, the cost to do that would be $1,000 per acre net of the Wetland Reserve Program funding. And that if we did 10,000 acres a year for 10 years on a rolling cycle, that we would always have 100,000 acres in the Wetlaculture inventory, which is to say that in a 10-year cycle, we'd need to raise $100 million of investment capital. So what we would do is set up 10 environmental investment bonds at $10 million each that are 10-year bonds with a 2% return on investment, which is in the range of a municipal bond. It's a little bit at the lower end, but when we factor in the upside of the payment for success, we can take that 2% and potentially increase it to 5%, and do one of these bonds every year, creating another 10,000 acres. At the end of 10 years, we'll have 100,000 acres that will keep rolling along. And so this is what the bond model might look like, right? Let's look at the value flows, right? So we have this desire to create these wetlands, right? And farmers own the land, and we want to restore that wetland. Well, we saw earlier it's about $4,000 per acre, but that the NRCS, through the WRP program, will fund about $3,000 of that acreage, which means we need to raise from the private market through a $10 million bond $1,000 per acre, right? So 10,000 acres times $1,000, it's a $10 million bond, will get us 10,000 acres. Every year we do 10 of these bonds, we'll have 100,000 acres. Once those wetlands are restored and they're up and running, they'll start to deliver ecosystem services, which then we can market. And as we saw earlier, that would be about $380 per acre per year. And that's with the trading ratio of 2.1, so it's the reduced value. And of that $380 that comes in every year, $250 could go to the farmer to reimburse them for lost value on their farm profits. $20, which would pay a 2% annual return on investment on the bond, would go back to the investors. Now we would take $100 out of that $380, and we would park it in a replenishment fund that would be used every year, 10 years, so we put $100 in, that at the end of 10 years we would have $1,000 to retire the bond, right? That 1/10 of that value is replenished every year for 10 years, and then there'd be about $10 left over to use to administer the bond. And so that's our baseline. But we also hope that because this program is so tightly monitored with audits and incentives and that sort of thing, that we can convince the markets of the higher quality of this and take that trading ratio from 2.1 to maybe 1.5 to 1, which adds more value in. And if we can do that, maybe we can get an extra $100 per acre per year based on performance, payment for success coming into play here. And if we can, $50 of that, half of that value goes to the farmer. Well, they're the ones that are doing the work that is, driving the nutrients into the soil, and all of this is paid based on, monitoring the soil and how much phosphorus, how much carbon, how much nitrogen is being stored in that soil, right? And so $50 goes to the farmer, $30 goes to the investors, right? So that takes a 2% return and adds 3% to it. Now it's a 5% annual rate of return, which is a very attractive rate of return in the municipal bond space. And it also puts $20 into administration of the bond and maybe creates an insurance pool in case we have some failures of wetlands and other sorts of things that comes into play. That we're managing the bond portfolio with some administrative dollars. And then, as another incentive for the farmer, remember that we said that it's about $132 or so of nutrients that are put on the field every year when they're farming. Well, in years 11 through 15, after the wetland is restored back into agricultural use, then that farmer achieves a savings of, call it $130 a year, which is additional incentive, which hopefully, if you look at those values, a farmer looks at it and says, you know what, this makes sense economically for me, and I'm not doing this because the government tells me I have to or because I face some fine, but that it's a good investment of my time and resources and money, and I want to be a participant in this process. So this is what the flows look like. So how much will the program cost? Well, the investors are paying for the restoration of the wetland, right? But they're not paying for the payment for ecosystem services, right? And so we know that that's about $380 per year. We also know that there's about $70 in conservation reserve credits per acre that we can collect. So that reduces the cost of the bond. But we also know that we're going after that extra $100 in additional payment for success, which brings our cost to a little over $400 per acre. And so if you look at that, if indeed a $100,000 inventory of wetlaculture acreage is the end goal, then that turns out to be about $40 million per year that needs to be brought into the model. So how can we fund it? Where will that money come from? Well, we might use a polluter pays model here, right? That the farmers are the ones that are responsible for all of that runoff, and so it's their burden to resolve. And the USDA suggests that the Ohio farm industry has revenues of approaching $10 billion per year. That if there's a levy put in place of a little bit less than 0.5%, that we could raise $40 million every year with the net cost of under 0.5%, which maybe is passed on to the consumer as it's just a cost of the produce or the corn or whatever it is. But that's one way we could do it. Or we could look at a beneficiary pays, right? That the Ohio tourism revenues are about $40 billion per year, and they're the ones who are being impacted because the harbors are closed, or because of the fish kills, or the other secondary impacts of the harmful algae blooms, right? And so if we put a 0.1% levy on the tourism industry, again, which probably could be passed through to the tourists, to the people benefiting from the actual experience, again, we could raise about $40 million or so and cover the cost of this. Now, that's a lot of money, and maybe it would be a blend of this, right? Maybe it's a 50-50 or something, but these are kind of two ways where this could be brought into balance with the cost of the payment for ecosystem services. So where do we go from here? Well, there's not very good information on the environmental or economic impacts of these environmental problems, right? Is this even a $40 million problem? Does this solution fit the need? And we don't know. So we have to do continued research around that. I think it's important that we continue to engage with stakeholders of all types, right? The farmers and the ecologists and the tourism industry and the citizens and government and everybody to engage on discussion around these potential conceptual solutions, right? We already see that the wetlaculture is an early stage testing, right? We need to continue with larger pilot scale trials, 100-acre, 500-acre sorts of things, right? And engage with other investment stakeholders on the value of this and does it fit, right? And maybe look at funding from foundations and others.